Have you ever truly felt small? I mean, not just small in a crowded room, but cosmically, profoundly insignificant? Go outside on a clear, dark night, far from the city lights. Look up. Every single star you can see, every twinkling point of light is part of our city in the sky, the Milky Way galaxy. But here's the secret. What you're seeing is just the glow from the neighborhood next door. The vast, mysterious heart of our galactic home remains hidden from your eyes. For centuries, we've asked the same fundamental questions. What is this Milky Way, truly? Where do we and our tiny solar system fit into this colossal cosmic picture? The answers are more incredible than you can imagine. So, let's begin our journey, not from Earth, but from the very edge of our solar backyard.
Think of our solar system not as a collection of planets orbiting a star, but as a ship sailing through a galactic ocean. This ship, our sun and all its planets, is encased in a protective bubble called the heliosphere. It's a giant, invisible shield created by the solar wind, a constant stream of particles rushing out from the sun. This bubble pushes against the thin gas that fills the space between the stars, the interstellar medium, protecting us from the most dangerous cosmic radiation. But what happens when our ship reaches the shore? Where does our solar system end and the great galactic ocean begin?
The journey to the edge is a story of slowing down. The sun's wind, racing at over 1,000,000 miles per hour, eventually weakens. It hits a boundary called the termination shock, where it suddenly slows, like a wave crashing on a beach. Beyond that is a turbulent region called the heliosheath, where the solar wind is compressed and heated. Finally, we reach the final frontier, the heliopause. This is the official coastline. Here, the sun's influence ends, and the vast, uncharted territory of interstellar space begins. And we have been there. In 2012, after a 35-year journey, a tiny probe named Voyager 1 crossed this invisible line and became the first human-made object to enter the galactic ocean. It was a monumental achievement. It proved we could reach the space between the stars.
So what's the first landmark we encounter once we leave our solar shores? Our closest neighbor, the Alpha Centauri system. Just 4.37 light-years away, it's a triple star system. Imagine not one, but 3 suns in your sky. The 2 main stars, Alpha Centauri A and B, are a dancing pair, similar to our own sun. But the third member, Proxima Centauri, is the real star of the show. Literally. Proxima Centauri is a red dwarf, a tiny, cool, and tempestuous star. It's so small it's only slightly larger than the planet Jupiter. But don't let its size fool you. This little star has a fiery temper, prone to violent eruptions called solar flares that can make it suddenly thousands of times brighter. And in its orbit, we have found something that sends shivers down the spine of every astronomer. Planets. One of them, Proxima Centauri b, is a rocky world, similar in mass to Earth, and it sits in the habitable zone, the region where temperatures could be just right for liquid water to exist. But living next to a star like Proxima is complicated. Because the planet is so close to its dim star to stay warm, it is likely tidally locked. One side is in perpetual scorching daylight, while the other is in an eternal frozen night. The gravitational pull from the star creates tidal forces 500 times stronger than what the moon exerts on Earth. These aren't just ocean tides. They could be stretching and pulling the very atmosphere of the planet.
So the question isn't just if there's water. The question is, could anything survive the stellar tempests and the gravitational tug-of-war? This is where our journey into the cosmos gets truly fascinating. We've left our solar system, met our stellar neighbors, and found a world that is both familiar and utterly alien. But this is only the beginning. In our next chapter, we will dive deeper into the mysteries of these alien worlds and ask the ultimate question: what does it truly take for a planet to host life?
So, we are left with a tantalizing paradox. We have discovered a potentially Earth-sized world, Proxima Centauri b, right next door. But it's a world of extremes, scorched by radiation, locked in a gravitational embrace, and lashed by stellar flares. The dream of a second Earth seems to be just out of reach. But what about the other planets in the system? The story gets even stranger. Beyond the habitable zone, we find Proxima Centauri c, a frozen mini-Neptune. This world is a ghost, 7 times more massive than Earth, orbiting so far from its dim sun that its temperature is a bone-shattering -380 degrees Fahrenheit. It's a world shrouded in mystery. It appears brighter than it should, suggesting it might be encircled by a colossal ring system, like Saturn on a monstrous scale. It's a beautiful, frozen relic, but utterly inhospitable.
And then, closer in, we found Proxima Centauri d, a tiny world with just a quarter of Earth's mass. It whips around its star every 5 days, so close it's practically skimming the stellar surface. It's a reminder that even the smallest of worlds can survive in the most violent of neighborhoods. But the plot thickens beyond Proxima. Remember the 2 main stars, Alpha Centauri A and B? Astronomers have spotted a faint signal, a candidate planet in the habitable zone of Alpha Centauri A, a sun almost identical to our own. Imagine that, a world orbiting a familiar sun in a region where water could flow not around a tempestuous red dwarf, but a stable, sun-like star. This discovery, if confirmed, changes everything. The dream isn't dead. It might just be in the house next door. Which brings us to the most human of all questions. We can see these new frontiers. We can imagine them. But could we ever truly go there?
The distance is humbling. 4 light years, 25 trillion miles. To put that in perspective, if we launched the powerful new Orion spacecraft, the one designed to take us back to the moon, on a direct path to Alpha Centauri, the journey would take over 100,000 years. You and I, and everyone we will ever know, would be long gone before it even traveled a fraction of 1% of the way. Our fastest human-made objects, the Voyager probes, are cosmic crawlers. There would need 80,000 years just to pass by the system. Clearly, we need to think differently. We need a leap, not a step.
This is where science fiction starts to become science fact. Enter Breakthrough Starshot, a project that dares to imagine a different way. The idea is breathtakingly simple and audaciously complex. Instead of a large, heavy ship carrying humans, imagine a stamp-sized silicon chip attached to a thin, light sail no bigger than a bedsheet. This nanocraft would be launched into orbit, and then, from a massive array of ground-based lasers, we would focus a beam of light, 100 gigawatts of power, onto its sail. For just 10 minutes, this tiny craft would be pushed not by fire and fuel, but by pure light. It would accelerate to an unimaginable velocity, 20% the speed of light, 130 million miles per hour. At that speed, the journey to Alpha Centauri would take just over 20 years. Think about that. A probe could reach another star within a single human generation.
It would blast through the system in a matter of hours, taking thousands of images and measurements. And then it would take another 4 years for that precious data to trickle back to us here on Earth. This isn't a guaranteed mission. It's a vision. The challenges are immense. The laser power, the sail material, surviving impacts with interstellar dust at relativistic speeds. But it represents a fundamental shift in our thinking. It proves that the galaxy may not be forever closed to us.
And while we look forward, the stars themselves are moving. In about 10,000 years, a small fast star known as Barnard's star will become our new closest stellar neighbor. It's an ancient red dwarf, twice as old as our sun, and yet it still surprises us with violent flares, defying our expectations of stellar retirement. We've even found a cold super-Earth orbiting it, a frozen sentinel in the dark. And then there's Sirius, the brightest diamond in our night sky. It's a binary system with a brilliant main star and a faint, dense companion, a white dwarf star, the corpse of a once giant sun. It's a glimpse into the far, far future of our own solar system.
Within 20 light-years of us, there are nearly 100 stellar systems, a mix of bright suns, dim red dwarfs, and failed stars called brown dwarfs. It's a cosmic neighborhood, bustling with activity, and we are only just beginning to map it. This leads us to the next, and perhaps most profound part of our journey. We've mapped our local stars. We've dreamed of ways to reach them. But to truly understand our place in the cosmos, we must turn our gaze away from these nearby points of light and look inward, toward the brilliant, crowded, and mysterious heart of our galactic home, the center of the Milky Way.